Create a custom tool. In this video, we'll create a custom tool, a cloud tool library, and modify a copied tool's parameters. In Fusion 360, we want to carry on with our CAM milling setup. To get started, we first want to navigate to our preferences, and we want to make sure that we have cloud libraries enabled. This can be done in the General section under Manufacture, making sure that Enable Cloud Libraries is checked. Once that's checked, let's navigate to Manage and Tool Library. From here, we should see a Document section, which will contain our design CAM milling setup and any setups that we have created. Since we haven't created any toolpaths, if we select these, it'll have no data. Then we have a Cloud and a Local section. The cloud libraries will be available anywhere you log in with your Autodesk account to Fusion 360. Local libraries will only be available on the current machine that you're using. So it's recommended that you use the cloud library functionality as long as it works for you, especially if you log into multiple computers. For our purposes, we'll be creating a cloud library, but you can also do this with local. When we get to cloud, we'll right-click and we want to select the option to import libraries. You want to locate the practicalcnc.tools file and select open. This will bring in a new tool library that contains all the tools inside of this library. There are face mills, and there are short and long ball mills and flat end mills, and there are lots of tools in here that we can use for our design. Typically, you'll have a tool library that is either machine specific, or if you have a tool room or a tool crib that you can access different tools, you'll have a library like this that has specific tool numbers attached to it. For our purposes, we're going to be using this practical CNC library, but it doesn't contain everything we need. For example, it has a chamfer mill, but we also need a countersink so that we can make the countersink holes in our part. So let's close the tool library, let's use Inspect and Measure, and let's take a look at these holes. The larger diameter is 375, and the smaller diameter is 0.188. So we need to have a countersink that can handle those values. We'll go back to our tool library and back to our practical CNC. We can begin filtering by hole making. We can take a look at countersink to see if there's any data here. If there's not, we can always go to the Fusion 360 library and see what's available. We have a 1/2-inch countersink as well as a 10mm countersink. When we see the 1/2-inch countersink, assuming it's something that matches a tool that we have, we can right-click and copy the tool. Then we can go back to our practical CNC library, right-click, and paste it. Once we've pasted it in our library, it's important to note that all the parameters that were contained in that tool have come along with it. For example, the tool number is 20. In this case, we want to right-click and edit the tool to make sure that all of the data matches. When we go to the cutter section, we can see the units are inch and the type is countersink. As we scroll down, we can see the material is high-speed steel, and then we can see the values. The diameter, which is the maximum diameter of the tool, you can see a preview here as well as a preview on the right-hand side. You can see the shaft diameter is 0.3. The tip diameter goes all the way down to 0, which means that it is large enough to get our 0.375, and it goes all the way down to 0, which means that we can drill and countersink the hole that we need. However, the tip angle is at 90 degrees. So the drill hole that we have in our part is actually not at 90 degrees, it's an 82-degree countersink. So this tells me that we either need to modify the tool or we need to modify our part. I'm going to modify the tool and I'm going to set this to 82 degrees. It modifies the countersink of our tool and it leaves the part as it was designed. We also can change other values such as the length below holder. This tool is sticking out pretty far and our countersinks are on the top of our part, so it can be much closer. I'm going to reset that value to 1 inch and leave all the rest of the parameters as they were defined. Note that it is tool number 20, and again, it's important that we understand the tool numbering scheme because that is how the tools will be created in the code that we output. We'll select Accept, and then we'll close. Anytime we modify or create a tool in the tool library, It's automatically saved, so there is no change to the design and there's nothing that we need to do to save that data in the tool library. If we go back into our practical CNC, note that tool number 20 is here and our filters have been reset. If you want to make a completely custom tool, you simply need to use the plus icon once you've selected the appropriate library. If we select plus, we can pick the type of tool that we want to create. In this case, we can look through our options and note that countersink is in the hole making section. Once we select countersink, we'll begin defining the cutter, noting that it comes in without a holder. In this case, again, it's coming in as inches because that's the units we're using in our design. The diameter of our tool, in this case, would be 1/2 inch. The shaft diameter is 0.3. The tip diameter was 0. The tip angle was 82 degrees. The overall length was 2 inches. The length below holder was 1 inch. And the shoulder length value was 0.5. And the flute length value was 0.375. So you can see that this gives us a reasonable definition of the tool. However, if we wanted to add a holder, we go to the holder section and we can pick from some of the ones we have. If you double click on a holder, you can use those from the samples tool library or any holders that you've previously created. For example, if we go into the sample tools and we take a look for CT40, you can see that there are several CT40 tool holders here. Some of them are made for 1/4 inch tools, and since our tool diameter is larger than that, it's not going to be an appropriate tool holder. However, if we have another cutter that's available at 0.25 diameter, then that means that this tool holder could be applicable. It is important that we match the tool holders with a real world tool holder and tool that we have. We can't simply create these tool holders to match the definitions we need in the software if we can't replicate them in reality. There are some that are blank in this case, CT40 blank 1 and blank 2, and you can also define your own new tool holder as needed. The process does take a while since you're defining the diameter and the steps, but it is important that you do replicate the holders that you have. From here, the cutting data will allow us to dictate how fast the spindle's spinning and what the values are for things like feed rate in the vertical direction and the cutting directions. For post-processor, this is where we would want to define things like our tool number. If we enter a value of 21, for example, it automatically changes our length and diameter offset values based on the fact that there is a background expression controlling them. This is important because these values are what's going to be used inside of your CNC controller, referencing the tool number and referencing any offset values that you've placed in that controller. While the diameter offset value isn't as critical on drilling tools, both the length offset and diameter offset are critical in general. You want to make sure that these values are referencing the same number as they are in your CNC controller. By default, it's going to be based on the tool number, but if you have something different, make sure that you do update these values. We're going to accept the new tool, and now we have two different tools. Again, using the same geometry. However, now we have one that's using a standard collet type CT40 and one that's using a different type of press fit or slim hydrofit CT40. From now, let's go ahead and close our tool library. And again, we don't have to make any saves to the design, but once we've made those tools, let's go ahead and move on.